But why do we care about this? Why do you even want to know this? You might be looking at this going, who cares? Well, let me show you why you should care. Because once you know the first 4 subnets, you now have the ability to identify the usable addresses within each of those subnets, and ultimately, in the end, the directed broadcast address. Because remember, you cannot give out the subnet ID to any of the devices. You cannot give out the directed broadcast address to any of the devices. You can only give out the usable addresses. And the usable addresses will change based on the subnet mask, because based on the subnet mask, the network IDs change. And since the network IDs change, the usable addresses would be different. And again, you might be saying, I don't care. Well, let's say you were given a diagram of a network, and there was a statement that went along with that diagram indicating that device A cannot talk to device B. Now you need to figure out why. And there's many different reasons why that might be. But one of the reasons that you want to weed out as being the reason why, or it might even be the reason why, is improper addressing. Because if devices are not properly addressed, and based on where they are located, could ultimately be the reason why they are not able to talk to each other. Because you see, devices in the same local area network need to have an IP address in the exact same IP addressing space. Going back to a street example, if I am on Main Street, then I belong to the same street as everybody else on Main Street. But if I belong to Elm Street, then I don't belong to the street as everybody else on Main Street. But what if I had addressing and information like everybody on Main Street, but I lived on Elm Street? It would be very difficult for the pizza delivery person to come find me, wouldn't it? It would, because they would then use the information they have and go to Main Street when I live on Elm Street. Uh-oh. Yeah, exactly. Same idea here. If you are not addressed properly, the end station thinks you might be part of Main Street when you actually live on Elm Street, or vice versa, and then the communication does not occur properly. And as a result of that, there is intermittent communication or no communication whatsoever. So addressing is of extreme importance, because all of our devices are programmed a certain way to behave differently based on the scenarios or experiences they have with IPv4 addresses. So with that in mind, if I have, in this case, 2 devices, one with an IP address of 172.16.0.5, and one with an address of 0.10, are they in the same subnet? Yes or no? Well, you can figure that out right now. Because based on our subnet IDs, you can see that 0.1 through 1.255, everybody in that range is part of the same subnet. They belong to the same local area network. They belong to the same VLAN, as an example. So as a result of that, yes, they are in the same subnet. But what about something like 0.5 and 1.5? Are they in the same subnet? Is 0.5 and 1.5 in the same subnet? Pay very close attention to those addresses, and pay very close attention to the range of values we have here. Notice subnet 1. It says 172.16.0.1 through 172.16.1.254. Is 0.5 within this range? Yes. Is 1.5 within this range? Yes, it is. Therefore, they are in the same subnet. You might have said no. You might have said no because the third octet is different in this case. But you know what? That doesn't matter here because of the values we see. Now, if we had a different subnet mask like /24 instead of /23, then yeah, if these were /24s, then these addresses would not be in the same subnet. But since we're /23s, they are, based on this information. So you have to be able to figure out the subnet IDs. Because once you figure out the subnet IDs, you can then ultimately determine the directed broadcast address. And then you can ultimately determine the valid range of addresses. So for example, we know that we cannot give out the subnet ID. So if we had an IP address of 0.0, can I give that to an end station? These are the last two octets, 0.0. So 172.16.0.0. Can I give that out to an end station? The answer, no, because it's the subnet ID. What about 2.0? Can I give that out to an end station? 172.16.2.0. No, because it's a subnet ID. Great. Likewise, the directed broadcast addresses we can. So what about 1.0? Can I give out 1.0? Can I give out 1.0? Yes or no? Yes or no? Yes, I can. Yes, I can. You'll be saying, no, you can't, Raymond. Well, again, it's based on the subnet mask here, folks. Pay very close attention. It says 172.16.0.1 through 172.16.1.255 are valid addresses in the first subnet. 1.0 is part of the through addressing, isn't it? We go 172.16.0.1.2.3.4.5 all the way up to 0.255. And then we have 1.0, 1.1, 1.2, 1.3, all the way up to 1.254. So in this scenario, this right here is a perfectly valid address in the first subnet that I can give out to end stations. I would not have been able to figure that out without knowing what is happening here and being able to build out this information, knowing the subnet IDs, the directed broadcast addresses, and then the values that are usable within each of those subnets. So you can't guess. Just by looking at a subnet mask, you can't guess whether two devices are in the subnet or not. Because now if I say, I want to compare 1.6 and 2.6. So 172.16.1.6 and 172.16.2.6. Are they in the same subnet? You know, without a doubt, 100% they are not in the same subnet. Because 1.6 is in the first subnet and 2.6 is in the second subnet. So you have the proof behind you now. You know, without a doubt, 100% that 1.6 and 2.6 are not in the same subnet. You're not guessing. You know. And it's all based on our subnet masks here. Subnet masks ultimately define the subnet IDs, and then all the other values fall within that.